Let's start with the Newmans. That's the priority. Draw the Newman projections. That's a typo down the indicated bond of each structure. So where is the indicated bond? So we need to look down C3, C2. What is the correct numbering of this? Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. I hope you know that's the correct numbering.
Yes.
The substituents will be on 2 and 3 in red. If you do the other way, 1, 2, 3, 4, 5, the substituents will be on 4 and 3. This gives you a total of 7. We usually want to give our substituents the least location possible. So that's the best numbers. Are we okay to that point?
Yep.
So the question tells me to look through C3, C2. C3, C2 means that my big brown eye should be here. That's where your eye should be.
Okay.
Why? This is my 3, and this is my 2. Now, if this thing said C2, C3, if this question said C2, C3, where would my eye be?
Our eye would be on the left side.
Exactly. So you have to be very, very careful. You have to be very careful with the instructions. Now, this is the rules for me. When the eye is on the right, my eye is on the right.
Mm-hmm.
The dash, anything with the dash is going to be on the right. Anything with a wedge, for me, will be on the left of the circle. And anything on the plane just stays on the plane. My friend, that is important notes. When the eye is on the left, anything on the dash will be on the left of circle. Anything on the wedge will be on the right of circle. Anything on the plane stays on plane. I give you 1 minute to write that rule.
Okay.
That is your lifesaver. Trust me, that's your lifesaver.
Okay. So the dash is always going to stay on whatever side the eye is.
The dash will stay on the whatever side the eye, yeah.
Awesome. Okay.
So now let's draw. I want a fresh diagram, and I'm going to use color code because you are a visual learner. I know you. I feel like I've known you for 10 years. Yeah. So I'm doing this just to make things very clear.
Okay.
Now we draw our eye so that we don't get distracted. And now I bring my circle. I used to have shapes here. I lost them. Let me just draw my shape of a circle. Which color is that? I need it black. That's brownish. Circle is black. That's the back. This circle. This is the other rule. Circle is always the back carbon. So which means for me it should not be black. My back carbon is the red one, right?
Yes, carbon number 2.
Correct. You see, it's always good to write the rules down. They guide me. Now, there is a CH3 on here, which was carbon number 1. It's going on the plane down. That's what I start with. You tell me where the red hydrogen should go.
The red hydrogen should be on the left side.
Because it's on the wedge, correct. And it's up. Left up, sometimes it's left down. The bromine is also oriented up, so it's right up. That's what our eye is seeing right now.
Okay.
Then we go to the back. Oh no, I should have again used black because wait. This is the back carbon, right?
Yeah, that's carbon number 2.
Okay, we did it right, only that because it's on the circle, we don't cross the line. I did it wrong. You do not cross the line if you are on the circle.
What?
Where is Br, hydrogen, and CH3 bonded to? Tell me.
It's on the back.
Which carbon is the Br, hydrogen, and CH3 bonded to?
The second carbon?
Where's the second carbon here in our Newman? What represents the second carbon on our Newman here?
The center?
The circle. We say the circle is always the back carbon, right? So the circle is the back carbon. You don't draw the lines into. You attach it on it.
So the entire circle is the carbon.
Yeah, you pretend the entire circle is a carbon. So just draw bonds onto the circle. Do not cross. I'll show you why when we draw the front carbon. Now the front carbon, we know that one we should see the lines. This is my ethyl. Right here, that's our ethyl. And it's right here. Now I'm crossing the circle because I'm not on the second carbon, correct?
Yeah.
The third carbon is here. That's why we are crossing now. Hydrogen will be where? The black hydrogen, where will it be?
The black hydrogen is going to be on the right.
And down. Chlorine on the left and down. And that will be the Newman projection for that molecule as seen.
Oh. Okay, that's not that bad.
Nope. No, it's not. The students are scared as hell to draw Newmans. I don't blame them because they don't know the rules, the guides. You are usually not given these rules, the guides I'm giving you here in the class or in the textbook. This is just me formulating some things to help you to quickly find it. Now, this time around, you need to go. This is the correct numbering. I'm not going to details. We need to go C2, C3. I'll draw the eye and wait on you.
Okay. So in this case, the back carbon is going to be
This 3.
3.
Yeah. Yep. So let's start with the back carbon. You see, it's easier for you to start with the back carbon, right? The things your eye will not see. So the ethyl group goes down. Again,
Wait, we're not supposed to cross,
we are not
right?
supposed to cross. Yes. That's what I realized. I said again, we are not supposed to cross. So that is the ethyl. We are not supposed to cross because it's tethered onto the circle, the carbon 3. Where
Okay,
is
so
the methyl group
on the
right
right
now?
side we're gonna get a methyl, and on the left side we're gonna get a hydrogen.
No, the had
Or
the I
on the right side. On the right side we'll get the
the
methyl.
had the I is on the left. The metal will go left.
I jumbled my words up. I got it. I got it right.
Yeah,
Oh,
you're looking at this situation right here. That's what you're using. The I is on the left. Okay, back carbon done, finished, finito. Front carbon, there's a metal group straight down, right?
we're
Carbon
gonna
number
bring it
one is a metal group.
right over.
Mhm.
We're gonna draw that methyl group right over.
Yeah, I'll tell you why.
Shouldn't
Uh,
the ethyl group come out the top?
uh,
Shouldn't the ethyl group come out through the top?
uh, no, look at the ethyl group. It's right here. The bond is going down. You don't see that?
Oh yeah.
This one, the bond is going up.
Yeah, okay.
Here, the bond is going up. But here, the bond is going down. I think you see that. Don't tell me you don't see that.
No, I see it, I see it.
Yeah. So anything down should go down. Don't make it up when it's not going up. Where will the beer go?
The BR is gonna go on the left side down.
No, I don't see this thing going down. Beer is
Listen,
at an angle. Metal's going this way. If you draw a line, the beer is really going up. It's a peace sign.
we're gonna just draw it right over then.
Yeah, don't force things. Just draw what you're given.
Okay.
And I believe that's where your problem was then. It's okay for them to align. That's what you're given, but it's not okay for the molecule because this is the eclipsed. When the bonds are aligned, they are eclipsed and they don't like it that way because the electrons in the bonds will repel. So this is eclipsed when the bonds are aligned. But when you have angles like this is the staggered. Now you get what I meant? Which one is more stable? So if I
Yes.
ask you which one is more stable, eclipse drawing or staggered drawing?
Staggered drawing is more stable.
Yeah, because the bonds are spaced out. The bonds are spaced out and they are not crowded. They are not sterically hindered. And this should be the answer for that. Look at
Can
it.
I ask can I
Huh?
ask why? Like
Huh?
why is the staggered more stable than
Oh,
the
would you want two bonds aligned? What makes bonds? Tell me, what makes bonds?
electrons?
Okay, would you want four electrons close together?
Okay, that makes sense. That
They
actually
will
makes a lot of
repel.
sense.
Like charges repel.
Okay.
Okay.
Um,
In staggered, the bonds are spread out 60 degrees away. You know, to make a circle is 360 degrees in math. So you have 60, 66 times. You get the staggered.
a lot of degrees. That's a lot of degrees.
Mhm. What did you
So
say?
I said that's a lot of degrees.
Yeah. So the next one is saying C3, C4. This one I will not draw. You will draw it on your paper first before I draw mine.
Okay.
Let's find out to name this. 1, 2, 3, 1. Okay, the right naming numbering should be like this.
Wait. No. Yeah, actually, you're right. So,
That's the right numbering. Do it. I'm coming. I'm going to warm my chai, my tea, the
okay.
microwave. Do it. I'm coming. I draw the answer for you.
From this side. You're gonna have.
Justin, I'm assuming you're done. Are you done?
Almost, almost, Professor Moses.
Okay, let me start the process.
Okay, yeah, I think I got it.
Okay, I'll draw my back circle. Let me find my red. My back will be this. And this gonna be left. That's right. That's plain. Do not cross. Do not cross. Plain up. Okay, so now that is done. And then now I go to the front carbon. Isopropyl crosses going down on the plane. The metal group left up. Hydrogen right up. I hope you have this structure.
We're good. To a
Did you
T.
get that as the answer or you do your own things?
No, I got it as the answer.
You got it correct?
Yep.
Okay. Do you have a question?
No, I think I'm good now. I'm ready for some chair configurations.
You just need to practice. Follow the rules. I told you to write the rules down. It will be so helpful. And the Newman projection will no longer be a trouble.
Gotcha.
I'm going to the other question if you don't have a question on this.
I'm ready for the other questions.
Those are chair conformations. The most stable chair conformation, let me write it. Let me write the rule here. So you would want big groups on equatorial. This is equatorial, this is equatorial, and this hydrogen right here,
It's
that's a,
axial.
yeah, it's axial down. This hydrogen right here is axial. So that's the rule. The most stable. So here we can draw Newman projections, yes, but when you're talking chairs, you want the biggest groups on equatorial to avoid crowding in space. We call that 1-3 diaxial interactions. On
Okay.
equatorial position to avoid 1-3 diaxial interactions.
So where the H is, we wouldn't want an axial position on the H, and
You just don't want an axial anywhere on the ring.
anywhere.
Yeah. Big groups. You don't want axial big groups on axial. You'll always have 6 axial positions. Could be hydrogen or whatever. But the most stable chair will be the one. See, the question asks you to select which one is most stable. The most stable one will be the one that has
The
the
biggest group on an equatorial position.
exactly. I'm going to slice this out. Then use a different software. This is radioactivity stuff. Let me open a new page.
Professor Moses, have you taken the MCAT?
No, I've not, but I've helped so many students. I'm wondering why I've not taken it because I don't have tuition for medical school.
Whew. You and me both.
I've I've so many medical doctors right now who have helped in MCAT. Okay, so let's see. Can you still see my screen?
Yes, sir.
So let's start with M. If I flip it, flipping here the rules. We always operate with rules.
When you
Yeah,
flip it, everything that's axial becomes equatorial, and everything that's equatorial becomes axial.
but you keep the axial, you keep the down and up. So axial down interchanges with equatorial down. The down stays.
Oh, okay.
Axial up interchanges with equatorial up. The up stays. The only thing you're changing is axial to equatorial, not the orientation. What I usually like doing is marking a carbon or 2 carbons, then I'll know what I'm doing. So now flipping just means kind of pressing these carbons opposite way. It's not a pancake flip like you would do in McDonald's. No, it's a press of up and down. So, for example, this carbon right here is supposed to be, right now it's supposed to go up. So the carbon next door is this one. This is the carbon next door, right?
Mm-hmm.
If that's so, then I see this guy is equatorial down. He must end up axial down. Does that make sense?
Yes.
I skip 1 carbon, I get to the isopropyl. Isopropyl is axial up. It should end up equatorial up. Like that. The way to draw equatorial, it should be parallel to one of the other bonds. So like this guy is parallel to this bond.
Okay.
That's how quickly you can tell the angle. And so my isopropyl here is right there. I skip one carbon, now I'm here. This CH3 is what? Axial lap. This bond is going to be parallel to one other bond. This one is parallel to this, and that's where the CH3 goes. Not backwards, because you already have an equatorial here. You have an equatorial here, so the other equatorial will be here because the axis is going to be down here.
Okay.
Now, which of those two is more stable?
The one that we just drew.
What is your reasoning, my friend?
Because the biggest group is on a
Because most big groups, there's a big group that is axial down back there. Most big groups are on equatorial.
that one's pretty straightforward, I feel like.
So you see right here,
Yeah.
that is crowding. It's crowding from position 1 to position 3. And that crowding, because you have two groups on position 1 and 3 relative position, crowding in space axial. And axial, we call this 1,3 diaxial interactions. Are you okay?
I'm trying to find I was trying to find my exam one where they had like a question similar to this.
Oh,
I was gonna ask
trust me,
that.
you have that question in there.
Yeah. It's okay. When I find it, is it okay if I send you a picture?
Yeah, that's fine.
Thank you.
So let's mark this and push him up. These ones we are going to push them down. This one will push it up, up. This one will force it down with our finger. That means our structure will now translate to this after the flip. You need to learn to draw chairs. Practice. Now I see that this is equatorial up. You see it's going up. This one is axial down. You see the bond is going down from the chair.
So we're gonna get axial down.
Yeah, the touch bureau is axial down. So after the flip on this carbon, which is this carbon, after the flip, we are going to go where? Axial down is gonna change to what?
Axial down will become equatorial down.
And it's parallel to the other bond. Very important to learn how to draw the angle. Now it's equatorial down. And then here, equatorial up goes where?
That's gonna be axial up.
Exactly, straight up.
Okay. And this structure is also gonna be more stable than the original one.
Because the chicken foot is bigger than the bromine, yes.
Awesome.
Either you're understanding very well or I'm teaching you good, or both.
Well, I think it's both.
Which is better.
I just wish it would have made this much sense on the exam.
That was before me.
Well, there you go. Now I have you for Orgo too, so.
I will refuse to tutor you for organic too,
Oh no.
unless you host me in New York when I come visiting in December.
Amazing.
Are
Yeah,
you
the
going to host me
best.
when I visit?
Of course, Professor Moses. Just give me time and date.
Your dad told me that he has a he what did he tell me? That he has a place that when I come visiting I stay for free however long I want. I laughed. I'll come in the summer.
Well, there you go. Just let him know.
How close are you to downtown?
Uh,
1 hour?
actually, the house that he was probably gonna offer is maybe like 30 minutes away.
Oh,
30.
that's close.
Yeah.
That's really close. Okay. You know the drill. Let's flip. So there's too many things here. Okay. And if I'm flipping, wait a minute. I think those are not the best numberings here because we are flipping, right? So the numbers, the labels should flip. A should go down. Let me find it.
Is the chair configuration just a cyclohexane?
Yeah, that's how the cyclohexane is in nature. It's never 2D, it's always 3D. You make a cyclohexane, he naturally knows to make a chair. He will not stay like this. This is if you are doing the bird's eye view, looking at it from the top. You'll see that. But if you're looking at side view, you'll see a chair. Why? Because the bonds have to be tetrahedral, maintaining the bond angle of 109.5 sp3 hybridization. That's why. Okay, so now I've flipped my chair, as you can see. A, B, C, D, E, F's, they are flipped. Whatever was up is now down. You tell me where the CH3 on A should go.
A is going to be axial down.
Okay, there
F,
it is.
F is going to be axial up.
This blue CH3, yes, it's gonna straight up.
And D is going to be axial up.
D, 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 D. Okay, there he is. He's an ethyl group.
And finally, C is going to be equatorial up.
There he is. Now decide, looking at the chair, who has the most B groups equatorial?
The top structure.
Exactly.
All right. Well, not that bad.
Very easy.
So now, actually, no, I think I had. No, yeah, I have one more question. It should be at the bottom of this one. It asks, is the cis or trans isomer?
You sent, is it the same file?
Yeah, this one should be on the same file.
Or
Yeah,
this, why is
it's
the Word document only taking strange. Let me download and see. Well, you know what? I don't need to download.
Yeah, so only question R. I think well, I know I understand PQ now.
Only question
Yeah.
okay. Is the cis or trans isomer of 1,3-dimethylcyclohexane more stable? Use chair conformation to justify. Okay. So the first thing I should do is to draw it. Now, if it says cis or trans, the first one I can have for the cis is methyl group up, or you can go methyl group down, whichever one you use, the answer is the same. This is a cis isomer. The other option is methyl group up, down, or you can use the second one, methyl group down, up. Once you have them like that, let me use this guy. I will draw two chairs that are flipped. ABC, ABC, flip, ABC. Same thing down here. ABC, flip, ABC. What do I have on my A? Down.
Uh, 1 second.
I wait.
Mm, A, okay. So on your A, how how would you be able to tell if the wedge is down or up?
Oh, you'll choose one of them as long as it's cis or trans. It says cis. Cis means same side, right?
Yes.
Trans is opposite. So which is why I say
So that
or.
uh, so in this case, it doesn't matter if it's up or down.
You can choose whichever one, up, or down, down. But see, this guy has a dash. Anytime you have a dash, dash means down, if that's what you're asking. We don't know if it's down, axial, equatorial. Wedge means up. It could be up, axial, or equatorial.
Okay. So then, would A add equatorial? It would add equatorial down.
No, because it's a dash, it's gonna, you see that A is already down. That's a guide to you that it should be axial down, straight down.
Oh,
Why? Because the carbon A is tipped down. You see that? It's tipped down. So if the carbon is down and your group is down, you better draw axial down.
okay, so then C should be equatorial down.
C will be axial down. The carbon is facing down.
Oh, so we're not gonna get any equatorial. I thought we could choose A, B, or
Now
no.
we flip. Once you flip, whatever that was axial down, you choose either molecule A or B. That's what I meant. Both of them are
Uh,
C's.
but how do we know that? How do we know it's axial and not equatorial?
Because the carbon is going down. You have two cases. You always have three equatorials and one axial. Okay?
Okay.
The carbon here is going down. Or you could have the carbon tipped up with one axial. So which case are we looking at for C? Are we looking at case A or case B?
Case B.
Huh?
Case B.
No, we are look for C and here for C and A we are looking at case A. You don't see that these two bonds are already going down. We have another equatorial here. This matches this. That's actually C and A.
So essentially, anytime we're adding an extra methyl group, we know it's going to be in the axial position. That's just a given.
No, it depends on whether it's going down or up and the structure of your chair.
So then how do we know that the hydrogens are equatorial and it's not the CH3 that's equatorial?
Here the hydrogen has a wedge, right? On C.
Yeah.
So it should be going up.
Mm-hmm.
So why would I put this hydrogen going down? Yet it's supposed to go up.
Okay, but then why isn't the hydrogen axial up? Why is it equatorial?
Because you're looking at case A. I'll
No.
ask again, where is C? Is C pointing up or pointing down? Is C sinking in the chair or is it protruding up from the chair?
It's sinking in the chair.
So it's case A.
Okay.
So you
So
have three equatorials, E, E, E. Where's the axial? The axial has to go down. Our
okay.
CH3 is saying that we should be going down. So the CH3 should go axial down.
Okay. So again, I'm gonna ask my question because I'm really confused. Why can't it be equatorial? Like
Why
I
can?
understand
Uh-huh.
the thing that you're saying about the carbon facing down.
Yeah,
Okay, that makes sense.
yeah.
Is it just like a rule? Is it like always whenever we're drawing something like that, it's just always know that it's gonna be down, axial down? Like
Yeah,
why
anything. Firstly, look at the molecule. The CH3 is a dash. What
yeah.
does dash mean?
Dash means down.
Which of these, if okay, dash means down and the carbon on the chair is going down. Which of these bonds in case A is going down?
Uh Axial down.
Yes. So anything you want to put down has to go axial down.
So there is nothing else that is
Down.
going down.
Yeah.
Okay.
Identify whichever case of the carbon you're looking at. Is it case A or case B? For case B, it's the equatorials that are going down. The axial is the one going up.
Okay. Okay, I think I'm understanding a little bit more now.
Okay, now let me help you even better. Look at A here.
Okay.
Yeah, so the 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 carbon here is going up. So I'm looking at case B, right? There's a
Mhm.
missing equatorial hydrogen here. See how this, where are we? The hydrogen here is going up, right?
Yes.
Okay, so let me change that. You don't want to switch the hydrogen. If the hydrogen is going equatorial up, he's gonna be axial up in the flip. So it's going to go axial up. Now what happens to our methyl group? Equatorial down. Why? We are looking at case B, which has 3 equatorials and 1 axial.
Okay, I understand now.
Yeah, now C is also pointing up. We are looking at case B. There's an equatorial missing here, and that happens to be the hydrogen down.
Okay.
No. It happens to be the methyl group down, because here it's axial down. It goes equatorial down. The hydrogen is up. The hydrogen is up. The carbon is pointing up. Anything that's up is only the axial.
Okay, I understand now.
Yeah, that's the case. So it's always either case B of the carbon or case A of the carbon. And it's the same thing here. I can choose this, and A will be going down, but here it will go equatorial. C means up. This is up. So I'm looking at case A. I'm missing an equatorial here going up. That's the CH3. Here, I have to maintain up. It's gonna go here. So both of these, both have equal stability. Why? One axial, one equatorial, and it's the same group. But here, this will be the most stable.
Because both methyl groups are equatorial.
Exactly.
Okay, that makes a lot more sense now. Okay, now I have one more question for you, and I'll get out of your hair.
Be quick, I have to connect with this other student. I know we
Okay.
started late. Uh-huh.
Do you have to go now?
Yeah, I have another appointment.
That's fine. If anything, is it okay if I send you a picture and whenever you're done, you could just get back to me?
Okay, that's fine. Let's
Thank you
do
so much.
that.
Goodbye.
Bye.